All right, so I'm going to do a couple of problems on your review for you guys. And then you are going to have the rest of it to do on your own, but there's two free response similar to the ones that we're about to do together. All right, so this first one is a calculator question, and on your test, there will be one calculator free response question to do. So this one says to let f be a twice differentiable function such that f prime of 1 is 0, and the second derivative of f is given by f double prime of x equals x squared times cosine of x squared plus pi. And we're just using this for x's between -1 and 3. And that is a pretty complicated equation, but it's not going to be a super big deal because we are going to be able to use the calculator on it. All right, so A asks us to figure out on what open intervals between -1 and 3 is the graph concave up, and we are going to give a reason. So don't forget that when a function is concave up, the second derivative is positive. And we are going to look at the graph of that second derivative, and so it's going to be concave up when the second derivative is graphed above the x-axis. That's where the function is positive. Now, I have to not use the exact calculator you guys are using, but it is pretty similar to it. And I already have this typed in. So we just go to y equals and type in the function. And then we only want this graph for x's between -1 and 3. So then that's what I made my window. All right, pause the video if you need more time to do those two things. Okay, so this is what the graph should look like. And what we want to know is where this graph, the second derivative, is graphed above the x-axis. So I can't see exactly what the numbers are, but over on the left side, where below looks like it touches 0 at 0, and then it goes below again, and then it bounces above, below, and then above. So what we want to do is find where it crosses the x-axis. So we're going to calculate a 0. So remember, to calculate a 0, we're going to do second, trace, and then choose number 2. All right, and then we have a little cursor. We want to go on the left side of the 0, hit enter, and then the right side. All right, now I don't have to hit enter again because this calculator is slightly different. You guys would need to hit enter a third time. Okay, so we have a 0 at when x is 1.25331. All right, and then there is a couple other zeros we are going to need to get. Okay, that one is when x is 2.1708. Right, and then 2.80249. Okay, so I'm going to go back to the notes and write that information down and just kind of remind you what we did. So over on the sides, we'll make these notes. All right, so we're going to look at the graph, f prime, and calculator. We want to be in radian mode. So if your calculator didn't like mine, you maybe were not in the right mode. All right, and then we found zeros. Let's put 5. As you in second, trace, and then choose number 2, 0. And then the graph, if I remember, looks something like that. Let me check. Yep. And this point right here was when x was 1.253. And then the next one, 2.71. Oh, just kidding. 171. And then that one, 2.802. Right, so the second derivative is above the x-axis when x is between 1.2353 and then 2.171. And then again, between this 2.802, and we're going to stop at 3. So we're going to say the graph of f is concave up on what I just said, so 1.253 to 2.171 and 2.802 to 3. And then the reason is the second derivative, so f double prime is positive there, or on those intervals. Okay, so I don't know if you can, it's too small for you to see all that at one time, but we'll try. All right, then for B, does f have a relative minimum, a relative maximum, or neither at x equals 1? And we're going to justify our answer. All right, so we need to go back up to the directions. So it does tell us when x is 1, f prime of 1 is 0. So that means that 1 is a critical number. So there is a potential max or min. But we don't have the first derivative to do the first derivative test. So we're going to do the second derivative test. So we would take that 1 and we put it into the second derivative, and then that will tell us if it's a max or min, depending on if we get a positive or negative. Right? And then don't forget, we can use the calculator. Okay, so I'm going to go to the table. All right, and then our critical number is 1. When x is 1, our second derivative is negative 0.5403. All right, so that would mean that that function is concave down at that critical number, and that would make the critical number be a maximum. So because f prime of 1 is 0 and f double prime of 1 is less than 0, so negative. You could write out negative there if you wanted to. By the second derivative test, f has a relative maximum at x equals 1. Okay, And then the last one on this one, does the graph of f have a point of inflection at 0? Give a reason for your answer. So we're going to go back to the graph again. And I think we already talked about this a little bit. So at 0, I'm going to change my y's a little bit. You don't have to. I just want to be able to show you better. That helped a little bit. But at 0, you can tell that the graph just touches at 0 and then goes back down, that the second derivative doesn't change sign. So that would not be a point of inflection. So because f double prime of x does not change sign at x equals 0, the graph of f does not have a point of inflection there. All right. So the next one is non-calculator. The rest of, well, you'll have one calculator question for you to do on your own, and then all the rest of the questions are non-calculator for your test. All right, so we have the graph of the continuous function g is shown, well, not really above, to the side, for x is between -3 and 3, and the function g is twice differentiable except at x equals 0. All right, and then we have a whole different function, and that's f, where we know f of 0 is -1, and the derivative is given by that function. We want to find the x coordinates of each critical point for f. So right now we're going to ignore g. We're not going to use it. And then we're going to classify each critical point as the location of a relative max, min, or neither. And we're going to justify our answers. So we have a lot to do. All right, but we already have the derivative, so that's good. So we want to find the critical numbers from the derivative by setting it equal to 0. Okay, and if you're multiplying and you get 0, it means that one of the things you're multiplying by has to be 0. But this function e to the x can never be 0. There's nothing that we can raise e to and ever make it 0. So when we're figuring out the critical numbers, we aren't even going to use it because there's no way it can be 0. So it doesn't contribute to our answer. So we just take the other part and set it equal to 0. And that gives us two critical numbers that we have to check out. And so what we'll do is our little sign chart that we like to do. Okay. Don't panic too much that you don't know what the square root of 5 is. And we aren't using a calculator here, but we do know the square root of 4 would be smaller than the square root of 5. And that would be -2. So let's just go with -3 and 0 and 3. So for this to equal 3, it would have to be the square root of 9/2, which is way smaller than the square root of 5. So we're good. Okay, and then when we plug in, we are going to plug in to this graph, or this equation. Okay, and so if we put in -3 squared is 9, and then 9 minus 5/4 is going to be a positive, and then e to the -3, e to the everything is going to be positive. So if I get positive for what's inside the parentheses, is positive. Right. And then if I put in 0 squared is 0, 0 minus 5 force is going to be a negative. E to the 0 is 1, so a negative times 1 is a negative. And the 3 is going to end up exactly like negative 3 was because we're just squaring it. And then e to the third is definitely positive, so it's a positive times a positive, which is positive. Now, the AP board accepts sign charts as work. They don't accept them as justification. So you still have to write out why the answer is what it is, but that will be acceptable for showing your work. All right, so let's write out our answer with the justification. So this is the first derivative we're talking about. So this shows us increasing and decreasing. So if you wanted to do that, you could. And then when the first derivative changes from positive to negative, it does create a relative maximum. So my first statement would be f has a relative maximum at x equals negative square root of 5 over 2. All right, now if we notice in the directions, it only asks for the x coordinate, so that's nice because we can't use a calculator. And then we need to give the reason why, and it's because f prime changes from positive to negative there. All right, and then our other statement should be about the other critical number, and f prime changes from negative to positive there, so that creates a relative minimum. All right, so your assignment for the next 2 days is to finish this review. So I know y'all got this.